Once you have all those kind of one-step transformations down, the next step is to combine steps. And so we've done already a lot of this. Probably the most important thing to be able to do here is move functional groups, right, from one position of the carbon to another position of the carbon. And we do this through subsequent elimination and addition reactions. Remember, for elimination and addition, we have a lot of control over the regiochemistry here. So for example, if you have this complex right here where you have this Br, and then you wanted to move that Br over a bit, right, from this tertiary to this primary Br, how would you do that? Well, you do subsequent addition elimination reactions, right? So here you do some kind of elimination reactions with a non-bulky base in this case, because we want to move it towards this side. And so then we can get an alkene right here. And then if we think about, we want to move it further to the left. So we want the bromine now, or the leaving group, to now go in the less substituted position. Remember, you can do this with HBr and ROR. That'll result in an anti-Markovnikov addition there, which will put your Br right over here. And now you essentially just repeat the process, right? So in order to go to this next step, we can also think about what we came from right here, right? If you stop at this top one, that was an anti-Markovnikov addition to this alkene. And so you can think about how you're going to link these two, right? You need to put an alkene, so you need some kind of base. But in this case, you want the less substituted alkene, and so you're going to need to use a bulky base, right? So DBU here, right? So remember, this right here is just a straightforward elimination. This one's an anti-Markovnikov addition. This is an elimination with a bulky base. And then another anti-Markovnikov addition. Right, so just use these subsequent addition elimination reactions to get where you want to go. And the same story with alcohols. With one kind of major caveat here. So for example, if we have this one alcohol right here, and we want to move this functional group around, you can see from the alkene, or the haloalkane, all we did was add a base. However, if we add a base here, what's going to occur is instead a deprotonation, right? So you can't go straight to elimination. You get this, right? This OH minus is not a good leaving group. And so it's kind of the same thing with the haloalkanes, with these alcohols. You just have to have one additional step, and that's to make it a good leaving group. So don't forget, we can tosylate these guys, add some tosyl chloride and some pyridine base. And you'll make this OTS group, and now this is a good leaving group. And so now you can do elimination reactions with a base, or you can do substitution reactions if you add a nucleophile. But don't forget, for alcohols, you have to make it a good leaving group first. And then one other good trick to know is that alkanes, we've only learned how to do one thing with alkanes, essentially, and that's bromination. We could do chlorination, but it's just not as good, right? So remember, you add your Br2 under your UV light, and your bromine will take the most substituted position, right? So with these little tricks, kind of piecing these together, understanding how these work, it'll make the more complex synthesis much easier.